people come, please write down, or if you cannot remember, write down your name, what is your field of specialization, and if you are currently employed, what are you doing, and what is your interest. And those who attended yesterday, they can also express their views on the presentation. You may say the presentation is too boring, or too long, too short, or it is interesting. So everything, either positive comment or negative comment, don't look at the faces. I mean, if somebody criticizes me, I take it verbatim. So I write poems. Somebody said, you don't know how to write. I accepted it. And that is his opinion. So please make a note, and everybody, unless you participate and you tell us, we don't know. So this is what my request, personal request. I don't know what is the policy of SIDBI. That is Aruna can tell that one.
Yes, sir. What exactly what you said is right, sir. So there is a need of our to introduce each and everybody, whomever joining in our meetings, sir. Because somebody I might known them, but each of them might not be known. That's why it is important to introduce themselves to the gatherings. So I request.
Because we have joined early,
Yes, sir.
so this is the time to, in fact, anybody can ask Aruna or me or any participants, so that we can keep dialogue, having our dialogue as everybody slowly. Now I see Mandeep Singh has joined. So like that one, before people talk, this is your opportunity to directly hear from horse's mouth. So please join with us.
Already this has been given to YouTube live streaming also, sir. And I'm posting in the chat box. The link will be posted in the chat box. And Surnarayan sir, I'll send to your WhatsApp also, YouTube live streaming. I request the participant side, please introduce yourself. It looks somewhat lively to this meeting also.
So, good evening, madam. My name is Shiv Ganesh, and I'm working currently as a deputy manager in electrical maintenance in 2 into 520 megawatt coal-based thermal power plant located at Visakhapatnam. That even yesterday conference also I have attended. It was really very interesting. And during the Q&A session, I got to know a very valuable information that Dr. A.S. Rao sir has said that brittle materials are even stronger than steel. This is the one sort of information or knowledge that I till now I have not known. Especially, I just once got an opportunity to just look at 1 feet by 1 feet Kevlar sheet once upon a time, and I was just playing with that sheet. The person said that it's very hard that this particular sheet it dissipates pressure. Kevlar that's made up of Kevlar. So the same property that Dr. A.S. Rao sir has said yesterday also, the brittle materials, they absorb the pressure and they try to expand it. And they are really harder than steel. This knowledge I have from yesterday's Q&A session. And you have also mentioned that what is my interest, that is, what is my perspective or personal interest in field, ma'am. Lot of things like satellite launching, that is rocket launchings or any missile launching, they have got their stations apart and their actual property, that is which possesses some sort of risk or danger, that is being placed at a far distance. Even in thermal power plants, I am interested in a technology where we can remotely operate the complete power plant, look at the maintenance parameters, like especially for the rotary parts and the parts that are vulnerable to heat, stress, and all those things, and accordingly conduct the maintenance or any in-person activity only when required. Otherwise, a lot of time, I think so. If the operation is continuously monitored in a remote manner, there is a technology, I have heard about it. That's a technology to even, operate a complete power plant in a remote manner and conditionally attend any problem or defect. That is my interest. Yeah, thank you.
Thank you so much, sir. Thank you. Thank you for your interaction with the gathering and your exploring your interest to the meeting, sir. Thank you so much.
Good evening, madam. This is Professor Vijaya. Am I audible, madam?
Yes, ma'am. Yes, ma'am. Please continue.
Yeah. Yesterday also, because of some technical issue, I was not able to introduce myself. I'm Dr. Vijaya, working as a professor of Department of Marine Biology, Vikramasingapuri University, Nellore, madam. And my research specializations are marine pollution, marine biotechnology, natural products, etc. And I am thankful to Dr. Aruna Madam for your excellent initiative and effort also in this direction. And simply I can say that being a life science person, I was not aware of the subject on silica and ceramics, but Dr. A.S. Rao sir has enlightened the essence of the topic in a simple manner where a layman can also understand the subject. I thank Dr. A.S. Rao sir for his simplicity in explaining the objectives of this lecture series and also the enlightened topic of the yesterday talk also. Thank you, madam. Thank you for the opportunity given.
Just one small suggestion.
Yes, sir. Yes, sir.
Who people who introduce just for, I mean, they could be shy, but just for instance, if they come on video, we can have a look at the person. In fact, like Dr. Vijaya, yeah, you can just come on video, and then if you don't want, you can be off. At least to know who the person is. In fact, there is going to be a talk, I think it's not tomorrow, day after tomorrow, in which actually different things, how the brain will register. In fact, that's the reason we specially required that Professor Rajeshwari to give a talk. Let us say I'm saying something, only video, audio, people understand. But if I have this video also, what happens is brain gets the strength because not only audio from the ear, but you can see, that means eye coordination. That means from two channels, brain gets the feedback that somebody is saying something and you understand it. In fact, that was the essence of her talk. It was real. So that is the reason I am just saying, just for a blink of a second, you can come on video so that we will know who you are and what it is. That is my personal request because I have hearing problem. That's the
Yes.
reason I'm.
Yes, sir. Yes, sir. Because of this signal and video resolution, I was not be online through video, sir.
That's my point.
Yes,
Yeah.
sir. Thank you, sir. Thank you.
Uh, because I have to say my introduction too. I am Dr. Appajusula Srinivas Rao. I'm a retired both scientist as well as a professor in the academia from point of view. And I am one of the oldest persons in this present audience. And my interests are right now, I threw away all my technical books because I didn't want to. My wife said, why you continue on? So that's why whatever is left over, I'm just talking about. My present interest is to write Telugu poems, and I am seriously involved in that one. And also trying to do something because I admire Sidvi Foundation, their global aim and how how Aruna is striving for it. So that and also trying to reward those who are to be recognized. That those are the two concepts I like to. So that's why I am participating and just once in a while I try to give lectures. In fact, you can yesterday people can see I'm gasping while I'm giving talk means I'm at the tail end of my technical knowledge may be there, but my abilities are slowly saturating. So this is my brief introduction. Thank you. Next.
Thank you so much, sir. Thank you. With the permission of Suryanarayana, sir, shall we wait for 5 more minutes, sir?
No issue, madam. No issue. So my presentation would be somewhere around 60 slides. I have slotted 1 minute for each slide, so it will 1 hour. Sorry. Thank you.
I request Dr. Vidhi Grover, ma'am. Could you please introduce yourself, ma'am? Shanmuga Selvan, sir. Dr. Shanmuga Selvan. Suryanarayana, sir, and Ganesh, sir. Anybody else from your end are about to join, sir? Other than our participants.
I think let's proceed. So in the meanwhile, people will join.
Maybe everybody is thinking it is at 7:30. I don't know. Or else you can start, I suppose.
No, sir. Actually, I had sent a meeting
Yeah,
link
yeah,
at time also,
yeah.
sir.
Yes.
I understand. So we can start actually. It is 7
Yeah.
o'clock. You
Yes,
can
sir.
just introduce the speaker and start. Yeah, everybody, please mute your this one because I don't want that unless you are trying to share your private conversation with all of us. Please mute your.
Yeah. So, sir, it's time for starting up of our today's session because sir is waiting since last 30 minutes, I think 30 to 40 minutes. Sir Narendra sir is waiting. So I don't want to make him to be waited more. I myself, Dr. Aruna, CEO, Siddhi Foundation, giving a warm welcome to one and all, whomever joined over here, dear participants and guests, respected guests and respected speaker. A very warm welcome to one and all and a very green good evening to one and all. So on this juncture, I wish to introduce today's speaker. Please allow me to give a brief introduction of Mr. A. Suryanarayana sir. Mr. Suryanarayana sir hails from Chirala and he is a retired Chief General Manager at the Neyveli Lignite Corporation, Neyveli. And sir joined NLC as engineering trainee after graduating with BTech in Mechanical Engineering from Sri Venkateswara University. And later, sir also received advanced training in power plant and O&M in Italy. And he was involved in power trading activities. And during sir's tenure at NLC, that lasted for over 37 years of service, sir had many accomplishments, including planning, construction, and execution of thermal power plant in Rajasthan. And under his guidance and supervision, the barren sandy land was transformed into one of the major thermal power generating hub. It's a really great thing, sir. And sir is a recipient of several awards, and some of sir's significant accomplishments include appreciation from former President of India, Professor APJ Kalam sir, and the Governor of Tamil Nadu, Mr. K. Rosaya. And after sir's retirement, sir settled in Hyderabad with ma'am, Srimati Savitri, and he has two sons, namely Balasubramanyam sir and Sivaganesh sir, and one of sir's son, Sivaganesh sir, is present with us. And I'm very happy, sir, to see both of you, the representation of Suryanarayana sir as a Sivaganesh sir. Thank you so much, sir. And we are fortunate enough, sir, to have a moving encyclopedia in thermal engineering. And I had forwarded this link to all my students, whomever passed out of mechanical and currently studying mechanical and EEE students also. And I hope they are also joining in our meeting today's talk, and they can get some knowledge from your today's talk, sir. Thank you so much, sir. And over to Suryanarayana, sir.
Thank you, madam. Thank you very much.
I request Srinivas Rao, sir, before starting off this talk, anything else to talk from you, sir, about Suryanarayana, sir?
I think that introduction is a self-explanatory, and today's talk is more towards the project administration and also through the mouth of a mechanical engineer, as well as almost a corporate member. That means very high in the management ladder. So this one will give us a perspective and understanding how the industry, top management look at the operational ins and outs. So with that one, I will just let the podium to Mr. Suryanarayana. Thank you.
Thank you. So today, my topic is on thermal power plant and intricacies involved in project administration. I am touching only an external major point what to be considered during the project execution. In Indian power scenario, our total installed capacity is 484,000 megawatts. You can just see the demand for this is only 273,000. That means we have enough capacity. It is not that conclusion that we can come, because yesterday Mr. Shivanesh was asking what is the extent of renewable energy impact on other thermal power plants and nuclear power plants and all. It was at very low percentage. Its contribution, renewable power contribution was very less earlier. Now you can just see it has even crossed the percentage level compared to thermal power. So we have a capacity of 34,000 megawatt compared to thermal power plant of 214,000 and 6,620 megawatt lignite. Lignite is an inferior quality of coal. But what is the problem? We can just go and depend on the renewable power. So what happens is it is seasonal. So solar, this renewable source major is solar, wind, and hydro. Hydro impact will be depending on the water availability in the dam, and solar depending on the intensity of our sun radiation, and wind is limited to a particular segment. For example, in India, we have a lot of windrows. They call it as windrows. Windrows effective for windmill generation in northeastern states, Rajasthan, Tamil Nadu, south of Tamil Nadu, near Tuticorin and all these places. So these installations can be only at limited places. You can see at whenever we see Tirumala also, windmills are there. But the efficiency of it would be depending on the windrows. So it is all seasonal outputs. So we cannot depend on exclusively renewable sources. So what is the next alternative? It's the nuclear power. Nuclear power is also a dominant contributor. But the problem is variation of the load. So for example, in morning session, that is after 5 o'clock, lot of induction load. Induction load means motors. Our agricultural motors will start. So that will take more load than commercial loads like lighting and all these things. So morning there will be a peak load. So we might have noticed that our frequency of transmission is 50 Hertz, 50 cycles per second. In different countries, this frequency levels are different. What happens if induction load is heavy, the frequency will fall. That is, it is trying to serve the load, but actual generation is not to that extent. So then what has to be done? It has to be supplemented. So the supplemented power generation should be a dependable source. That is thermal power. So morning load, it has to cater. And evening, immediately after 6 o'clock, lot of lighting load. This public load will come. And from 10 o'clock or 9 o'clock onwards, industrial load will come. That will go to the peak level. So the demand is not smooth line. It is actually a bell curve like thing, a reverse bell curve. So it goes to the peak, maintain, and then falls down. So to sustain this particular load, an average level of generation has to be supplemented. That is only possible by thermal power generation. That is why we are, despite of this pollution norms, the stacker emission of carbon dioxide, carbon monoxide, sulfur dioxide, and a lot of effluents. That is the liquid effluent. We have to run the thermal power generation with a lot of corrections and all. That is the importance of thermal power generation. Next. See what is actually what happens in thermal power plant. So we need fuel, that is either mine, it should be a pit head mine power plant, or it should be at fuel supply potential area, that is sea coast. So a lot of thermal power plants are installed near the sea coast. And a lot of power plants are also there near the coal mines, such that transportation cost will be reduced. You can see that Ramgundam thermal power plant, we have got Kothagudam coal mines, and Tuticorin power plant has the sea coast. We receive the import coal like that. So the fuel is the one source. Then what? The thermal power generation is a basically principle of enthalpy and entropy of stream property, that it exhibits a lot of internal energy when it is heated. In a closed environment, when a temperature is subjected to the water, it becomes steam, then it is saturated, and it becomes gaseous state. It takes voluminous amount of space. So when that is constrained, the volume constraint will lead to the pressure development. That is called Rankine cycle. In Rankine cycle, the pressure rises once the steam is constrained to not expand. Not expand means it is constrained inside the volume. That is the boiler. And this steam constrained stream of high pressure is allowed to pass through turbine. This is the turbine. So the boiler will come to the turbine. Then the pressure is released. The impulse turbine, reaction turbine, there are different types of turbines. That is, the pressure loss will not be there, or the pressure loss will be there. But at one particular stage, the total pressure, whatever has been generated in the boiler, is given in the turbine. So it impacts this particular energy by rotation of the turbine is converted to the kinetic energy. So coal chemical energy is heated. The chemical energy is transformed through steam into a kinetic energy. This kinetic energy is converted to rotation of a generator. What is the electricity? Electricity is nothing but when a magnet is cutting the electro potential cables, or they call it as stator. EMF is generated, electromagnetic force is generated, EMF is nothing but the voltage. So what happens is in generator, magnetic impulse will be given through the rotor, which rotate, the turbine is coupled to that, and that particular thing will rotate. And it is connected to a stator where the copper cables will be there. So EMF is generated in the cables. That particular voltage would be very low, but current will be very high. A simple equation, 2 into 3 is equal to 6. And the same equation is 3 into 2 is equal to 6. So this job is done by transformers. So it reduces the voltage, increase the current. If it reduces the current, it increases the voltage. So when current is high, in the transmission, the current is notified as I. And resistance of this current flow is given as R. Resistance, ohms. Ohm is a current, and this resistance is there. I squared R is the loss or energy that is dissipated or energy that is consumed. That means for line transmission, we should use high voltage and low current such that I squared R. R is the resistance level of the cables. So to mitigate that particular thing, the generated voltage is transmitted through a transformer circuit, and these transformers will go to the line. When it is at the receiving end, the transformer is again converted into again same principle, 2 into 3 is equal to 6. When it reaches there, then it will become 3 into 2. Then it will be low voltage and high current. And these sort of combinations of transformers will make the power requirement to the need. That is, somebody may require in thermal power plants, some motors are run at 6,600 volts, some are run at 3,300 volts, some are run at 400 volts, and our household voltage would be 230 volts. So depending on that, the transformer systems will cater to the requirement. This is what is generally done. There is one more thing. This turbine, when the steam is enormous amount of pressure is, that is, for example, for an output of 200 megawatt, almost 150 kSc. That is, we are on the ground with a pressure of 1.033 kg per cm square. One atmospheric pressure. So for 200 megawatt generation, the steam is generated to a level of 620 tons per hour at a pressure of around 160 bar, 160 times of our pressure on retaining our on the ground. This particular pressure in turbine, when it is expanded, at the end stage, it loses all its energy and it is almost it becomes actually that we maintain vacuum such that all the steam will be sucked out. This particular steam sucked out has to be, it is a very, very valuable water. It is a demineralized water. This is what is the circuit of this water. It's very costly water. That is, the water that is used in the boiler should be completely cleaned. So this water should not become waste. So what we do is, in cars, we use radiators, same way. A radiator system like thing will be there in condenser. The steam is cooled through an external cooling media, which is nothing but cooling tower. This cooling tower, we might have seen this sort of structure, very big structure. Because of this parabolic construction, venturi will be created. That is, whenever we enter into a temple, gopuram, we feel the airflow. That is because of this venturi effect. Same venturi effect, it is a shallow casted cement construction. So the water that coming from the turbine end is just dumped at around 10-meter height, and when it is falling, this airflow will lift all its internal heat and evaporates. So whatever is the cooling media that has consumed the heat from the steam is cooled down, and again it is sent back. This is what is the system of thermal power plant. I think in a very, very basic way, I have explained what happens in a thermal power plant. You can see this is the small a picture of what happens and whatever I have told is the fuel is coming here, it is burned, and this water that is coming from the DM plant is converted into steam, and it is expanded in the turbine. Turbine rotates the generator. Generator is covered to the transformer. Then it goes to the grid. And this whatever is expanded steam is cooled down through this particular water, which is used by the cooling tower. Now, what we have to understand is a managerial aspects. Okay. Government will not allow you to leave this smoke with a limit of carbon dioxide, carbon monoxide, sulfur dioxide. And similarly, the vapor that is coming out should not cross limits of the chlorine level. In chlorine, we add the water because to contain the algae and all. So the water that is coming out should not be this one. And the temperature which is operated should not, difference in temperature should not be more than 10 degrees. Like that, environmental norms are there. Similarly, this coal after burnt is converted into slag. This slag is again where it has to be dumped. It is ash. what we will do with ash? If we allow it to settle down on the earth, it will not allow any vegetation to grow. So there is a methodology with which these ash ponds are constructed, and this ash is allowed only to settle down in that particular area. Or you can use this ash in cement industry, this dry ash. Dry ash, if it is collected in the dry ash, this dry ash is collected in, if dry ash and with limestone and with some other chemicals of bonding it becomes this cement. In cement factories, they collect the ash that is converted into a useful product. It is a byproduct of the thermal power plant. Yesterday I was raising the question of Dr. Rao, no? The silicon dioxide, the marcosite with silicon dioxide, once it crosses the limit of that is, they call it as initial deformation, fusion, and initial deformation, fusion effect. So this boiler, when it is firing is occurring, ash is thrown to the wall and it stuck on the wall. If it is sticking on the wall, it becomes an insulator. We are selling, aluminum oxide. This having high capacity of retention. It becomes a protection wall. So here, this protection is a negative effect for me, because for giving the same amount of heat to the boiler, I need more energy, so more coal is burned. So for that, some steps are taken, and this slag is also in some plants is used as a catalyst for steel industries. So like that, the industries also form around the thermal power plant, and this discharge has to be let out to an useful product, and we cannot let it down. And then it will become a government control norms. This becomes a administrative constraints for running a plant. They will say close down the industry. Now what happens? This electrostatic precipitators are there, which sucks all the burnt out gas, and it drops down into dry ash. So this dry ash only is going to the cement industries. Now what they are telling, after this collection of the dry ash also to an extent of even 90+%, it is collected. That is why some stacks of high efficiency, we don't see smoke. If smoke is seen, means the efficiency of ESP is less. So if the level of sulfur dioxide is more, that is, it goes and settles down, or if some rain comes, then it will become H2SO4. It adds with the atmospheric water, then condense down and falls. So there is a constraint. What they are telling is, now you have to have a lime plant, desulfurization plant. Now it has come as a regulation. Earlier it was not there. When I was in service, no desulfurization plant was there. Now for any approval of a plant, you have to have a desulfurization unit. So you have to use lime, and you have to create a lime water when the gas is falling, and this sulfur is sucked out. These are all certain regulations that follows. So in the following slides, I will show you. I have explained to you very, very positive way. What is seriousness in running a thermal power plant? You can just see in the following slides. Utmost care has to be taken in the power plant from its design stage itself, followed by stringent erection policies and O&M practices. Even there is an agency called Central Electricity Authority, Central Electrical Regulatory Commission, CERC. They monitor how you are performing, how you are following the guidelines and all. Because it is nothing but, you see, in our household we use gas. It is nothing but a controlled bomb used to regulate by regulation for a commercial purpose. So my father, in earlier ages, when this cooking gas was introduced, he was fearing to bring it to the house. A lot of thought was like that. Then we we understood there is a regulator will be there, so there will not be any danger. So slowly, same way, boiler is a controlled bomb. So we have to have stringent safety measures, or otherwise a lot of accidents will occur. Because in thermal power plant, we use a lot of cooling oil, we use a lot of furnace oil, we use coal, we use substances of high pressure in boiler, and we use rubber elements in conveyors. These are all high fire prone environment. That is why I used to tell my colleagues also, those who are working in thermal power plant, when they come home, keep them happy. Because so as long as that we take care of the plant, everything is running normal, everything is okay, good. In one of the night shift, I was just going around, I had a doubt. That is, the consumption of steam was rising. So I sensed that there is a puncture in the boiler. I told my operators to watch what is the consumption and whether there is any sudden pressure loss. I went to the boiler, went around in lift to boiler, lift will be there. Suddenly there is a blast. That is, they call it as fish mouth. Fish mouth means fish is the open mouth, you know. So after retaining so much of its capacity, yesterday Rao also was telling, you know, it is a molybdenum steel, molybdenum nickel embedded high alloy controlled heat treated steel. It is capable of withholding the pressure and temperature. So once it reaches, a pinhole will start developing, then fish mouth will come. Suddenly the pressure loss will be there. And what happened? Immediately I called in the walkie-talkie. What happened? Boiler says unit got tripped. Like that, it is a high protected protection warranted plant. You can just see, please don't go by distorting videos. But anyhow, these are all some serious videos. This is just imagine. Suddenly this particular thing erupts. It is an oil fire. In turbine hall, the root cause was not knowing, the upkeep was not up to the mark. Somewhere some leak had occurred, root cause has not been identified. It is a summer season in Chhattisgarh. Immediately it caught fire.
Well, we can't see the video. Please.
Video has not been
see-
played.
That's what I was telling. So see, while design stage itself, what is the level of intricacies that we have to follow? That is an indication. These do happen. See, what as an administrator, what we have to do is regular monitoring. You don't believe anything of what visually you are seeing. What visually we are not seeing, only we have to think. And there is one type of construction called, a lot of chimneys will be there. That is why, Aruna madam, I told your students to see, because it's an awareness program. See what is the level of maturity at which the engineer should be capable of. They are also armed persons. So physically, they should be physically, mentally. EQ level should be more, not IQ level. Emotional quotient. So if something happens, what I have to do? That readiness should be there. And coming to the point, chimneys you might have seen, it's a very tall structures of 270 meters are very high structures. How it is casted? So in earlier days, we used to wells, small rings will be there, we will lower it down. It is not like that, you know. It is a 270 meter, 300 meters. they identified one design technique called slip-form technology. The slip-form technology is nothing but you can see this frame in 3 meters. It will cast, it will set, again rise on the same casted this one. Say we keep in a pot and then we'll fill the water and again on the top of it we put one more pot like that. So on green set, that is called green set cement, the platform raises, it goes to the 270 meters. Every day or every alternative day, it raises to an alternative estimated level of 3 meters. So if it is a rainy season, we should not keep the same norms. We have to stop the work. This sort of considerations have to be taken care during the chimney construction, cooling tower constructions or all. You can see what has happened. If the quality of the cement is not all right, it may also lead to a lot of accidents. It was heavily raining, there was thunderstorm, and in one of the chimney construction, it will also just, I will show and cut the, stop the video. So these people, they went, see, chimney had collapsed because of thunderstorm. People were just sitting underneath and it has unwanted incident had occurred. So in erection stage, what is the amount of importance that we should consider for the preset bricks, preset concrete strength, reinforcement, steel rod quality? These are all very, very essential because it has to run for any power plant runs for normally 25 years. And if it has to run for 10 more years, then the life extension program will be there. So far, considering that particular thing, the design stage itself specifies that whether you have to use an EN8 or 2062 rod, I'm sorry, it's a hardened steel, torsioned steel, or soft steel. What is the type of steel that you have to use? Metallurgical aspect. It has to be taken very, very carefully because we give to a contractor. Contractor normally is in for financial obvious advantage. They may try to dilute the quality. You cannot compromise in thermal power plant. And this particular, if it is 20 marks for a thermal power plant, it is 120 marks for nuclear power plant. The Chernobyl is one of the world's well-known. Its cooling media, there is any interruption. What havoc it will create in Kyiv. So these are all the design considerations we have to take very, very carefully for thermal power plant. This is also maybe in Tamil, a Vallur plant. Is also a fire accident like this. See this smoke, I have faced such problem. So immediately what action we have to take? We have to evacuate everybody and all. See, in this stage, I would like to tell you. Yesterday I told you, my interaction with my not intermediate, my blessings with AVJ Saab. I started explaining him this and that and all as a fool. He is a technical wizard. What to explain to him? I do not know what to tell. So I just called him and I brought him to the control room and I started explaining him what are all these things. He intervened. Yes, okay, very good, no issue. What is the safety aspects that you are telling? He asked one technical word called security level. Security level means not CIS or military or some policeman or something. It is not like that. See, these things run by computer systems. How many computers will be there? If one fails, what will come the next? What will be the next? What will be the next? So if nothing comes favorable, what do you do? So I take the plant in manual mode. If that also fails, what will do? I said, I will shut down the unit. He was checking only the preparedness of the managers for facing the emergencies. So these are all such things. Similarly, this is one EOT crane in a turbine. This EOT electronically operated tower crane. Each blade, these blades cost more than $10,000. This is a gas turbine. This has occurred in Netherlands. And while it is lifting, there is a problem with the gearbox. And the gearbox snapped when it is being lowered down. Slowly, when it is getting lowered down, it snapped and it has fallen. So it has led to a lot of time loss, a lot of material loss, and a lot of disturbance to the project execution. So whenever we are taking any action for correction, amount of design consideration safety level to be taken is very, very high. Similarly, these rubber materials, which I told you. This is the last clip. I will not show you any disturbing video. This many times I have faced. Night shift, somebody will weld and go. He will not cool down that area. And slowly, when it comes in the morning, it will catch fire. Once the rubber catches fire, we cannot control it. And it has to be dumped out after the conveyor belt is cooled down. This is one of the conveyor belt fire. It actually melts down the steel structure itself. The amount of heat that it generates is more than the melting temperature of steel. Similarly, this is one of my experience in the Rajasthan power plant. I was lifting a 20-ton girder to a height of around 30 meters through a P&H crane of high capacity. It was settled because it is in a sandy area in Rajasthan. Due to some reason, what has happened? This boom, the lifting boom, collapsed. Fortunately, because of my faith of God, the operator was very, very smart. He filled the boom such that it has fallen on an open area. So there was only a damage to the crane and there was no major loss, only crane. So what statutory bodies have told, whether this operator is having authorized license, whether this crane has been tested properly, whether the rope was tested properly, when it was tested, validity is there or not. These things start coming. So as an administrator, during the erection stage, we have to follow these things. What are the cranes that they are using, whether it is certified, whether the operators are authorized or not. See, just you can see the crane also, if it is a 30-ton crane, means it doesn't mean that it lifts 30 tons. If the boom nearest to point, it is 30 tons. If it has to lift at a distance, it will lift only 2 tons. There is a movie, 30 Chambers of Shaolin or something. One small stone will be there at the end of a stick and he will be asked to lift it. Very difficult to lift. But in hand, he can lift it. It's a length at which you have to lift at a low weight to give high amount of pressure on the crane. So this crane loading curve also has to be properly seen. Boiler safety rules encompass a range of practices designed to prevent accidents. So to control this particular thing, what has to be done is we have to enforce a lot of specific rules to address boiler, safety valve, fuel handling system, combustion control, and prevention of any oil, explosive materials, etc. So main causables of industrial boiler explosions and all these things, there is a lot of precautions to be carried out regularly. And we have to have periodic auditing. They call it as thermal safety audit. Every one particular time cycle, they have to audit and give certification that this plant is okay. And every year it goes for boiler statutory inspection. That is, they physically pressurize the boiler and see whether it is withstanding that pressure or not. So these statutory regulations have to be strictly enforced. Precautions to be carried out in steam boiler. And occasionally, I told you, the efficiency have to be tested, the pressures, vessels have to be tested. And its continuation of the certification also has to be ensured. See, if anything of high pressure explodes, the amount of damage to the structures and RBG nearby will be very, very, very high. Its implications would be too much. Apart from any unwanted human loss, the implications of continuance of the industry, continuance of power plant, restoration process, and satisfying the regulators so that it is okay because of this particular thing only it has happened. To prove it, it becomes a hectic task. How to avoid it? So there are government norms, boiler norms, environmental norms, welding standards, and what type of welds have to be used for what structure. So for rails, so train going in rails, it is not fully casted rails. So after a particular length, it has to be welded. They use a technique called thermic welding. So some places of stainless steel welding is required. This TIG is called a tungsten inert gas welding. These are precautions, the design aspects that has to be taken. So if you are interested, I will show the norms. This I will just proceed. And this particular thing is environmental conditions for design. This is a particular boiler designed for a particular country of a particular place cannot be taken as a standard for the other country. For example, in a garment factory at Bangladesh, they constructed the plant with some design on the top of a already set lake. The building had collapsed. In I think it's Los Angeles or California, there was a club. It has collapsed due to heat. And there was one construction in some foreign country. After completing of it, it was not able to handle the air conditioning system. This was a lot of heat was there. So the norms that are considered for a design at desert on the capacity, on the means a heavy wind flow, cannot be taken as the same thing as a sandy beach at seashore. So the soil investigation at particular range, particular area, particular field has to be exclusively carried out and cannot be universally used. This particular video alone I will just show. Okay, just see, this is a garment factory in Bangladesh. It was constructed on a lake. This particular building was constructed and it was to be dismantled because heat it was taking was not considered during the design stage. So this is the structure which I told you, in US. Snow. See, in Russia, the same design aspect of Indian continent cannot be compared. It goes to minus temperatures. the design aspects also to be based on the local conditions. Okay, so far I have shown you something which is disturbing. I will show you now how we can mitigate. When we plan everything, not only plan design and all, we have to consider the mitigation methodology. You can see the greenery near the cooling tower. It is allowing this chlorine levels and all controlling is there. And this is almost we are maintaining like a green plant. We are living in a park or a thermal power plant. I told you this is a high dangerous zone, but this is the environment at which the plant is constructed. So, for this dust and ash control or coal powder dissipation, a lot of greenery has to be taken. You can just see it is a jungle. So, I will tell you the basic differences of casual taking of design aspects. Any welding rod is same. You go and ask a welding rod, he will give you a welding rod. But all welding rods are not alike. Like all humans are not alike, all welding rods are not alike. See this here you can see there are E7016 is the code. Here E8018 B2 is the code. Because this E means electrode, 80 means 80 pounds per square inch, the weld can withstand the strength. And you can see the one is the position of the welding. It is upward welding, horizontal welding, vertical welding. And the last digit is what is the coating that is creating on the weld surface. So for different applications, we have to use different welding rods, different welding methodology. Like I told you, in trails, we have to use thermite welding, stainless steel welding, we have to use for the MIG, metal inert gas welding. The rod will be continuously supplied and it will be in the enclosure of an inert gas. This is one of the example. E6010 is electrode of 60 lbs per square inch. And one is the position of the welding. And 0 is high cellulose sodium coating of the flux on the top of weld. So when the structures are welded, when structures are this one, a proper check on what type of rod he is using, what type of weld method he is using, how to document it. This is one technique called QAP, Quality Assurance Plan. For each and every stage, there will be quality assurance plan. What is the material he is using? What is the welding he is using? What is the methodology he is using? Who is doing the job? Whether he is qualified or not? And what is the final checking methodology? And who has to check it? Whether it has to be witness or check or radiography test is there, non-destructive test has to be conducted. Everything will be decided in the QAP. You can see one of the QAP model of a BHEL plant. So they go very, very meticulously because the design level of 500 megawatt, beyond 500 megawatt. Actually, Shiva Ganesh is working at 540 megawatt, 520 megawatt, 520 megawatt. The pressure level at which the welding methodology has to be used has to be properly used. Similarly, the quality assurance for electrical. You can see it's not dropping down. So this particular document has to be physically monitored at all particular stages of erection. This is what I wanted to just explain. What is the material he is using? What is the inspection that has to be done? and what is the tolerance limits and all. For each and everything, there is a mechanism of controlling called QAP. So whenever anybody comes for a fabrication, they will say, first you submit the QAP. So based on the QAP only, I will accept, I will reject, I will ask you to redo it. Like that. This is called QAP. And here this QAP also material test certificates. So IS 2062 Indian standard. IS 2062 is mild steel. It's a mild steel if any sheet is being used. If it is specified in the QAP as IS 2062, and we'll have to ask him what is the test certificate for the IS 2062, whether it is tested in the NABL labs, government approved labs. He has to submit the certificate. What do we have to document? This is the aspect of quality assurance plan. This quality assurance plan is there. The actual execution. We have taken what are all the seriousness involved in a thermal power design, what are the mitigation methodologies, and what is the statutory obligations that has to take, and how to proceed. So I am a owner. I have money, either government or private or whatever it is. I want to have a power plant. So what has to be done? Whether I have knowledge? No, I don't have. So I have to depend on a knowledgeable person, a consultant. So we have to engage a consultant. So for any thermal plant, the efficiency of the total plant depends on the advisor, consultant. He advises at each and every stage. That is why it is a reciprocating mechanism. And safety monitoring agencies. We are responsible for each and every stage. The safety monitoring mechanisms by statutory bodies, safety standards, accident, everything. So this purchaser, with the approval of consultant, will award the work to contractor. Mostly the contractors will be Engineers India Limited or L&T or such big companies. So this contractor, whether he can do it, no, he will get the contract. He will be runs in crores. He will subcontract. When he is subcontracting, to whom he is subcontracting, we have to have a monitor mechanism. So with that, this subcontractor has to be approved by us. He will have to submit a document of that I am going to execute the work through L&T. The contractor may be some agency, and this contractor will give it may be even a foreigner. So he will locally he will contract to L&T. So L&T will execute the work. Whether L&T do it, no. He will engage the work to a local contractor. So at what level of minute areas we have to go and check the QAP? See, this subcontractor also have to be approved by us. So we have to approve the consultant, depend on the consultant, take the advice of him, award the contract, then award the subcontractor's acceptance, then subcontractors also. Whether the subcontractor fabricates everything and directs everything, no. There are certain bought out items, ready-made items will be there. Say if it is a building, we are giving a contract to a contractor, whether he manufacture bulbs, he will buy Bajaj bulb or Philips bulb. So this is called bought out items. Similarly, in thermal power plant also, there will be a lot of bought out items. Whether we can accept each and every bought out items? No. So in the contract document, what is the approved bought out items? So similarly, welding rod, Advani Erlingcon, or some D&H welding rod. These company welding rods only I will accept. So these bought out items approval. And whether we can accept any sort of transport agency. Some items may be airlifted, some may be by ship. Some may be by road, and while it is transported from the road, what is the weight and what bridges it is crossing, whether the bridge will be capable of withholding that weight, we have to monitor. So that is where the transport agencies, whether he is able to monitor to that minute level, micro level. They call it as marine insurance. Similarly, who is the erector? The subcontractor, the erectors, subcontractors, everything is there. They manufacture, they supply everything. Who will assemble it? Whether he is qualified, whether he has done the earlier any construction like that, and what is the testing mechanism he is following, whether he knows the knowledge of QAP, whether he can properly visualize things of seriousness. Because altogether everybody is responsible for statutory authority. Whatever is the little thing that it goes, again, mostly this thermal plant person will look cool, but with very high pressure. It's something like a swimmer is facing turbulent water. But it is a challenging thing. Once it is habituated, it becomes a practice. Now I am coming to the aspects of the QAP coming into the actual stage. Scheduling. Which work has to be done at what particular time? I have shown you earlier slides. What are all the different items? Turbine, boiler, transformers, cooling towers. Cooling tower is constructed by L&T. Boiler will be erected by Engineers India Limited. There are so many agencies there. Each and every agency we call it as a package. So for each package, they will submit the networks called L1, L2, L3. This is the project execution. Actually, yesterday, one Mr. J.V. Rao has come, he's an expert in this. They use one technique called Primavera MS project for scheduling. So what inputs have to come at what time and what are all the control mechanisms that has to come, it comes in the per network. These schedules in the L1 network is broadly given with the pre-design when he has to submit the drawing, when he has to submit specifications, when material has to be supplied, when it has to be erected. This particular thing will come in the L1 network. L2 network is a sub-level to that L1 network. L3 network is a ground level. It goes to subcontractor, what schedules have to be done. Every day we have to sit together in review meetings and we have to say, today you have to finish this. This is the QAP, this is what is the plan. This comes in L3 network. In following slides you can see. It contains a lot of packages. These heads of L1 network is a major milestones of the project are to be highlighted in the schedule. When it has to be, engineering has to be completed, that is design. Engineering means design. And when it has to be fabricated, when it has to be erected, when it has to be tested. Like that. L2 network is the details of pre-construction activities finalized within 3 months. Time he has to submit. Is a broader breakup of not exceeding 1 month. So in that particular thing, L1 network, he will give you a broader network. 41 months schedule means he will give supply within 5 months, 6 months and all. Here in L2 network, in that 5 months, what are all the things that he is going to do? He has to give the schedule. This is L2 network. Actually, this L1, L2, L3 is the terminology used for the project execution. Not only for thermal plant, but for any industry. L3 is at execution stage. This will be decided by the purchaser and the erector. A minute level, day-to-day plan. It goes to a plan of only 1 week. Or after the end of the week, there will be weekly review meetings. So these are all the progress monitoring mechanism. Hopefully, Mr. Rao has to give me a feedback whether I'm boring or I'm proceeding all right. Is it all right, Rao? I think he's in an unmute condition. So this progress monitoring mechanism, basic engineering, detailed submission of drawings, approval, bought out items listing, manufacturing activities, and inspection, testing of equipment, performance guarantee test and all. So now the time is coming to close. I will also run fast. These are all different methodology of monitoring the progress. And acceptance of material, I told you already, quality assurance plan. At quality assurance plan starts from material acceptance. I call it as MDCC, is a very, very vital document. Material dispatch clearance certificate. It is actually certified by the inspector. One person will go to the site, test the equipment. He'll say it is meeting to the requirement. The material can be accepted. This MDCC approved material only has to go for the erection. What is its checklist? And this material, this is on payment methodology. The delivery should synchronize with the payment schedule. Material receipt, that is in containers, in ship containers will come, only documents will come. It has been inspected, the container has come. This is called material receipt error. That is physically we have not inspected. The third stage is material verification certificate. Material verification certificate is actually we open the container and we see whether the material is conforming to that, whether they give an embossing stamp of inspection, the inspection agency. We will engage some inspection agencies or the consultant will go or purchaser will simply go. So this material which is supplied on verification whether it is accepted. On MVC, that is material verification certificate only, the material will be handed over to the contractor. This is called MVC. Similarly, MIC is the inspection. This is for spares of the equipment. What are the different spares that he has assured and whether he has given the list or not, spares are there. Erection format. They approve the same principle of supplies, QAP, for fabrication stage, L3 dates based on fabrication drawing, what is the welding rods he has to use, what is the process he has to use, like that he has to meticulously follow. Same way, the different welding practices. What type of welding should be used for what incident. And we have to test the welder and approve the welder. That welder only has to do the purpose. For that one, L2 approved welder will be there, officer will be there. He will test the knowledge level and capability level of welders before allowing him to do the erection stage. These are all the welding practices provisions. So for everything there will be an main boiler pressure parts and all. It should be welded by an IBR welder. Indian boiler regulation passed welder only has to do. So they will check that certification test and approve him. Then only he has to do the welding test. So if there is any severe root porosity, blowhole, cluster porosity, cracks, lack of fusion during the test, he will be bluntly rejected. The welder will not be allowed because of it. Once everything is erected, it goes inside. We cannot see it. Criteria for welding procedure specifications is one of the standard practices that we follow for maintaining the welding records. Fabrication. Fabrication also is QAP will be there, and once this QAP is there, material test certificate, whether it is actually the material approved has been used or not. Erection. Similarly, the fabricated items put together will go for the erection. Next stage is like L1, L2, L3, fabrication, erection. Once the erection is over, there are certain government regulated formalities which have to be taken. These are all the advanced bank guarantee, comprehensive performance bank guarantee. Advanced bank guarantee is we pay for material 10% in the advanced stage itself. Once you start supplying the material, the bank guarantee values will come down. These are all the financial implications. Liquidated marine cum insurance. That is, while in transport, I told you, crossing the bridge, some damage occurs, the insurance who will bear? So the contractor has to take the marine insurance. Marine cum erection insurance, why they use the word marine is not for only seawater, it is a universal word. Road or air or ship, they call it MC insurance. Workman compensation, anybody is injured, what is the compensation has to be paid? The contractor has to take the marine workman compensation insurance. Liquidated damages, he promises certain things that I execute the work with this. If there is any lapse in it, what is the penalty that has to be levied on it as an administration process? LD clause will be applied. Documents that has to be submitted, DP test, that is dye penetration test for the welding, radiography test, holiday test. Holiday test is nothing but coating, if it is properly coated or not. If there is any gap in the coating, then that is holiday. That is a gap is there. Instrument will give indication, then it has to be peeled out and again coating, like that it test. Hindrance register. One contractor creating a hindrance to the other contractor, whether it is acceptable, and we have to record it, such that in LD class, the delay is not on account of X, it is because of Y. For regulating these things, hindrance register will be there. Some commissioning process. Fabrication is over, erection is over, and once fabrication erection is over, one particular package is completed, is called mechanical completion. Once is mechanical completion is readiness for a preliminary operation. And we conduct the preliminary operation with specific conditions of the test. Then it goes to the preliminary operation. One is mechanical completion. Once mechanical completion is over, you will have to conduct the preliminary operation. That is all mechanical, electrical, controls and instrumentation, DM plant, everything put together. It has to integrate and do for preliminary operation. Once preliminary operation is allowed, okay, then it go for the initial operation. Initial operation means under different load parameters at 50% load or 100% load, whether the plant is maintaining the norms. Then trial operation. Trial operation is a contractual word. That is, for this particular load, it has to run for so many days. This is the trial operation. Then provisional takeover. So after the successful trial operation only, provisional takeover will occur. Once provisional takeover is taken, it follows the warranty period. The plant has to be given warranty by the suppliers and all. We have to maintain the formalities of maintaining the warranty levels. Then PGCs, performance guarantee test. Performance guarantee test is conducted under completion of warranty level also. The plant has to give a generation level of 500 megawatt with this steam input, with this coal consumption, with this chimney emission levels, with this DM consumption. These are all the performance parameters. So whether the PG test satisfies to the total plant construction. Then final takeover. Once this is completed, we take over the plant. We will say, okay, you are completed, you can. Then we have to declare the plant for commercial operation declaration. It has to go for commercial operation for the method. These are all the different steps of an administration level of a thermal power plant. I think at the last few slides, I have gone to Vande Bharat speed. You have to please bear with me. These are all the different. If everybody is well versed with all these terminologies, he is well versed with project execution procedures. Thank you very much.
Thanks a lot, sir, for your wonderful and very elaborated talk, which can give a nice idea, those laymen for this thermal power plant also, sir. Thank you so much. And I request the participants, this time is the interaction and the question and answers time. So please ask any of your questions or doubts to sir.
Hari Om, ma'am.
Thank you, ma'am.
Good evening, ma'am. Good evening, sir. I'm Dr. Madhu Sharma from Haridwar. I want to give a suggestion. As coal produces lot of pollution, can we use charcoal instead of coal in power plants, thermal power plant, as it is light and plant-based, and like bamboos and many plants can be used to convert it into a charcoal?
It can be used. I'll tell you, basically, coal family, it goes as wood, peat, lignite, anthracite coal, bituminous coal, bituminous coal, anthracite coal, then your charcoal stage, graphite. Then for each type of coal is used for a different particular purposes. So lignite, why I am using lignite is a premature coal. It is next stage of wood peat lignite. It is a dried wood. Why lignite is being used is this is the availability of the material for meeting to the present requirement. See, charcoal based plants on you can see the sugar factories, the molasses. And once it is extracted, it is being used for the boilers. So this is being used, but Jharia coal mines in Dhanbad area and all is very, very rich in high quality of calorific value and is used for metallurgical purposes. Iron plus carbon only is the formation of your steel family, you know. So for metallurgical purposes, certain coal is only used. The other coal cannot be just. One more difference is coal, if it is allowed, it naturally becomes ash. So it is self-ignition. The material will go, the heat value will go waste, you know. Before it is the purpose of resources available, we have to make use of it. But there are certain areas where wood is used, pulp is used, waste material is used, paper is used, biogas is used, biomass is used. But depending on the availability of the cheapest fuel, with the regulations of statutory body, the fuel is used. This is what is my idea.
Let me explain that. It is not everything can be used. The reason is, first of all, availability, but mostly what we can see industry concerned is the heat value. If I burn so much, what will be my last product, which is ash? Because ash has to be disposed of so many other things also. In fact, lignite itself is on the lower side of good coals. And even below lignite is your charcoal. So it has a different applicability than using in the power plants. So that is basically a nutshell. And let me continue. I have a small comment. Every step of what the presenter has told is at the higher level, because although it looks like one smooth going talk, it channels out into different branches. And everyone reports to the board level. So that's where cumulative effect he talked about in a successful start to the end. In my experience, I mean, most recent, before I retired, is one aspect of this program management, particularly in the power plants. Well, for myself, I'm from the nuclear side, I mean, which generally I don't talk for Indian public or India because we have our own limitations. In one aspect, there is another thing called a regulatory board regulation. We try to protect the public as well as the industry. When we do that one, in fact, in just licensing on the welding aspect, it is not that simple. Directly, not only the welding methodology, welding procedures, welding techniques and all, there is a whole agency that looks in terms of licensing. Those guys really goes into nuts and bolts, and they are not easily satisfied. Always they will ask for required for additional information. That means for safety considerations, they try to really hunt for a fault. Before doing that one, I mean, this itself is one branch that reports to the person like the speaker. In this small segment, those licensing people are what accepting group or whatever it is. They have their own technical team. They assess, and if they are not satisfied, they come to another branch, which is like a research. So I'm in one of that, I'm an expert in some aspect. They come to us, and either we test again and do that one, or we contract and test and come to a conclusion, and we'll feed them back. So the licensing will digest, and generally they keep on asking for additional information. So without knowing or on purpose, the bureaucracy goes on and on and on. That's why major decisions cannot be done even at a lower level. Then you can see how corporate management level thinks of. Because everything they blame. So they want to protect. So this is actually, although he talked about this welds, just weld technique or weld performance or weld survivability, that means life cycle prediction of weld. We really do quite a bit of research. That's where I'm personally involved. So I know how difficult is it to bring back, to feed to the upper management level before they sign. In fact, actually, when we are doing, well, pardon me, thermal is more important, but in nuclear, we have to sign with our blood. So that is how such a stringent system will be. It's really a wonderful presentation. And how many eyes they have. I mean, actually, I personally feel the top management, everybody is an Indra, because according to Indian philosophy, Indra is supposed to have 1,000 eyes all over his body. So the top management has to look any simple thing with 1,000 eyes. So this is how, and although I was a little bit worried whether it will keep on going, you completely finished it in your time stipulation. It's a wonderful presentation. It really brought, in fact, although I spoke several talks and all, I never spoke half of my technical expertise, and I will not also. I mean, here I talked, but in Indian diaspora, I will not talk. And so at least I was happy at least to see, because what happens is when you have an electrical circuit, once you put on the switch, the bulbs will light at different places. So during his talk, the light has it lit in my mind one corner of which subject which I won't share to anybody else. So it is really, I personally feel wonderful presentation, a vast scope of subject and condensing into a small 1 hour talk. Thank you very much.
Thank you, sir. Thank you.
Others, please ask, because this is a golden chance for you guys. So unless you ask, you come out and ask, he won't tell. After this one, it will go away. And then even if you aspire, you don't get satisfied with your question. Please ask every speaker, all 7 days. This is not a just conference type talk. This is a special, distinguished speakers, at least most of them whom I know, distinguished speakers talk. So you are hearing through an expert's mouth, horse's mouth. So please use this opportunity and talk. Though there are no simple questions, no difficult questions. And if it is a difficult question, you extract the information from him. That is useful not only to you as he speaks. It is we all share his expert opinions. Thank you again.
Thank you, sir, for answering my question, and I congratulate you for wonderful presentation. Thank you very much, sir.
Thank you, madam. Thank you. So we have a plan to visit Haridwar. We will come.
Definitely, sir. Okay. Sure, sir. You're welcome.
I already got that assurance, so don't worry about it.
Sir,
Yes, please.
if I, that is myself, can I ask question?
Yeah, please. Open.
Sir, I am, that is, you very well know that I am working in coal-based thermal power plant. If I want to give my generation to the grid controller, in India, there is a concept called availability-based tariff. That is 24 hours before I have to schedule my generation to the grid controller. But due to some reasons where the grid control, if he feels that if he gets an extra benefit from the wind or solar or any other resources, he asks to back down my generation. And he encourages that. Sir, why it is only for these gas plants and coal-based thermal power plants, we are being restricted to this availability-based tariff system, that is declaring 24 hours before the generation that we are that we promise. Why we cannot put these actions to the renewable sources? I am asking this because every time the grid controller, he regulates the operation to ask me to back it down. It gives immense pressure to my boilers. It is it creates problem for the operators to operate the boiler, and the boiler is also under constant stress because it goes to the pressure point at a very rapid stage and it comes down to the pressure at a very rapid stage. So could you, my basic question is, why the availability based tariff concept is not still implemented to solar, wind, sir?
See, for the other persons also to make it as a simple way, because normally, to explain it, a simple way is easily to catch. We hire a car. Whether I use it or not, I have to pay the rent. And for usage of the car, depending on the kilometers, I have to pay. If I don't use also, I have hired the car, I have to pay. This is called capital cost and running cost. The plant has a capital cost. I have invested so much of money for installing the power plant. I have to have this much of revenue basically. This is called power tariff agreement. In power tariff agreement, this particular concept of capital cost is embedded as a fixed cost. In variable cost also, what they do is the car, sir, I am giving you a car, you can run for 50 kilometers, and beyond 50 kilometers is chargeable. Same way, for different configuration of the fuel that is being used, different level of minimum level of generation it has to maintain, or otherwise boiler will shut down. That means normally the coal-based power plant, there is a norm between 40 to 50% load. That is why mostly these 500 megawatt plants are running at 250 megawatt. Why this particular thing is, as you are telling, the wind potential, all these things is forecastable now. They are anticipating the renewable source, which has to be used. If you don't use, it's waste. So what you can do, you can conserve the fossil fuel or coal or whatever it is. But you have to maintain the minimum kilometers of the car. Same way, minimum cost revenue has to be maintained. Or otherwise your plant will shut down. So they ask you to bring down the load to 50%. That is why your plant is running it at a minimum level. Lignite boilers are still worse. You cannot go load below 60% because it's a poor quality of lignite fuel. In coal-based plants, it's 40 to 50%. That is 200. Normally, what is the minimum level of your 520 megawatt? They ask you to bring down around 250.
Our plant, it is 270, sir. 270 is technical minimum, sir.
Yeah, 270 means 540. It is a 540 unit or 520 unit?
520 units, sir.
520 units.
520 unit, and the technical minimum is 270 per unit.
So this is called its technical minimum. Why this technical minimum is there? This technical minimum of all power plants will be maintained, and the gap is built by the forecasted level of generation that is coming from the hydel, thermal, hydel, wind and solar. Why this is not done for nuclear plant? Once it is synchronized, you should not disturb. It goes as a controlled system. They will not touch. Otherwise, it have to be, even for shutdown process also, it goes under a very, very stringent rules and regulations. The variation of the loads is possible only in thermal plants. This technical minimum is there. With this technical minimum only, you can bring down the load such that the gap that is coming from the renewable source is bridged to meet the demand. Demand is nothing but maintain the frequency at 50 Hz. Even you are running at 270 megawatt, if the frequency falls below 50 megawatt, you can go load, you can raise the load, you can raise, because suddenly some plant trips. By the side of your plant, one more plant is there. If that trips, frequency will fall down. Once the frequency dips, you have to raise the generation such that you get the revenue. That is, you have hired two cars, one car is under shutdown. Okay, sir, I will run, sir. He will run for more kilometers and he will get the revenue, same way. This is called unscheduled interchange charges. You might be knowing because you are well versed with this ABT procedure. This ABT procedure is every day of 24 hours is divided into 96 segments. That is, each and every plant has to predict what is my generation level in the next 15 minutes. This 15 minutes will cover as a day. We have to give in advance. If suddenly plant trips, we lose a lot of money as penalty, and they give a schedule, revised schedule of raising the loads of adjacent thermal power, cheaper thermal plants, or bridge the gap between the renewable sources. This is what actually is done. And another doubt that you had is remote operated power plant is the question that you have asked.
That is, I have stated my interest in that remote operated power plant technology.
Yes, it is there. It is there. I have when I was the unit head of the plant, there was some system computer error due to some reasons. So what has happened is a contractor is Ansaldo Energia, Genova. We contacted him over phone. So this is what is figuring. A lot of errors are coming and plant is running. What I have to do? Whether I have to go for a close shutdown. This is the question of APJ Kalam also. What steps you take at emergencies is only his question. Whether you are prepared, whether you are EQ level, emotional quotient level is good. Whether you are emotionally, you are balanced. So this is the decision we have to take. We counseled the experts of everybody cannot be an expert, A group only gives a consolidated decision. They said, sir, it is safe to run the boiler. Don't go for any shutdown because which damper will close, which damper will open, we do not know. Computer is in error, mind is gone wrong. So what I have to do? So there is a mechanism of remote operation. We connected this plant through a password to Genova. The computer panel, which you know, has been taken over by the foreigner, and from there he started operating the plant. It is available. And in one of the plant in Italy, I saw in the panel, at the corner of the control panel, one person was sitting, and I asked him, is a boiler operator, is there, turbine is there, a generator operator is there, what he is doing? He is telling he is controlling 5 hydro plants remotely, sir. So he is figuring it in remote. So this is there. And dependence level makes plant operation not advisable, because it is a sensitive industry. We cannot take it granted for a remote operation. So that is why provision will be there for any mitigation of emergencies, but operation is done locally. I think I'm clear on that.
Yes, I understood, sir. Because someone may come into the network and do some sort of hack or something, and he may go for complete grid blackout or something like that.
Adding to it, Dr. Vijaya, he's a marine biology specialist. He has interacted with Dr. Rao. I so happened that I went to Rameswaram with Dr. Rao, and a particular Pamban bridge. So he has taken me and he has shown the steel plates, MS plate, and they were testing the salt deposition level and capability to maintain the structure strength. They were having some laboratory also. Just I remembered when he was telling about marine biology, I remembered that Pamban bridge chemical capability of bridge retention. They were having some lab with permission of Rao. I mentioned it.
Sir, may I ask one small doubt, sir? Small
Tell
question.
me, madam.
So if analysis of this coal is affecting this thermal power plant, and if so, how, sir? Can you explain, sir?
See, the quality.
Approximate and ultimate analysis of coal. It being done with the thermal power plants in quality control and quality assurance. So what may be the effect of that analysis on this evaluation of thermal powers?
Okay, thank you. See, normally Actually, the total presentation is for the board presentation, and it contains 200 slides. One of the slide is your question. That particular thing I have removed and I made it as compatible for public. No? What happened? There is one plant which was constructed, and coal supply agreement was disturbed. So what immediately they did is, bluntly, they have entered into a contract with the imported coal. Imported coal that is coming from Malaysia and all is having very high calorific value. And the coal agreement they have entered with some our local coal is having low calorific value. That is, for the same quantity of coal, the heat content that it comes is in a different way of your approximate analysis. I am telling in a literal meaning. The heat output that is coming vary for the same 1 kg different, and for some same 1 kg is different. When they have migrated the coal supply from Indian coal to the foreign coal, the boiler collapsed. Because it is designed like that. It has to be used for that fuel only. That is why regulations have come for mixed fuel technology. So the boilers will be designed in particular stage that if it is, the values vary from this level to this level, also it should cater to the requirement. So a mixed coal also is being done. I think Vizag plant, they get coal through rail and through ship also. I do not know. I may be wrong. So this coal is blended. It's a blending of coal. And for blending of the coal also, the design should be acceptable for retaining the values. So it is not advisable, but the design defines between what level of variations of the coal quality the boiler can withstand. This is what is my response. Similarly, coal, Singarani coals and all having 40% ash. That is why our Kottagudam coal mines or NTPC Ramagundam power plant is located near the Kottagudam Godavari Khani area, so the transport cost will be less. If transport is very high, we have a plant at Lucknow, Kadampur plant and all. The coal supply from a different end. So we have to do is washing. We have to wash the coal. This coal washeries. This coal washeries, ash will go. What will happen? The value will rise. For the same 1 kg value, so the heat output would be higher if it is a washed coal. So these are different technologies will be used. But for different qualities of coal, the boiler should be designed for holding the variations, is my opinion. It is being done. It is being done because there will be disruptions of coal supply. So immediately they enter into contract with some Malaysian supplier, and he will supply the coal, and they will blend it and then supply.
Thank you,
I
sir.
have extension. I have the same comment, extension of the previous answer. Indian coals are very poor. They have sulfur, you can say contamination. You have ash, high ash, so many things. And these coals are of different varieties. Good coals are very few. And they go through a lot of processes, coal washing to remove some coal gasification, all those things. But good coals are not used for thermal power plants. Good coals are exclusively used for the steel manufacturing.
Metallurgical purposes.
So for that one, they use because the limitations for blast furnace is very high. It's very limited because too much slag is a lot of problem. So that is the reason different the poorer varieties of coal are being somehow after the cleaning or after washing, whatever it is, are used in thermal power plant. This is my understanding of use of Indian coals in different arenas. In fact, at one time, the lignite, they started making briquettes and used for household purposes. The reason is industrial demand is less because of the poor quality. In houses we can have for cooking. Now, of course, this modern ladies, they don't use coal at all. They want only gas. Without gas stoves, there is nothing. So that has gone. So lignite briquettes came only because of this one ash content. The white powder left over after burning is all inorganic waste product. Others, please ask questions.
I request any others from the participant side, please ask your questions too, sir. Still, we have 15 minutes more time. We got an opportunity to meet all stalwarts. They are experts in their own expertise areas. So we couldn't meet them again and again. So please try to utilize the opportunity. And I could found here two more speakers, our next speakers, Dr. Rajesh sir. Sir also belongs to chemistry background. I request Dr. Rajesh Jadhav sir, could you please speak a few words regarding this talk? And could you please interact with the gathering, sir?
Maybe she stepped out. Anybody else, please ask questions.
Rishwari ma'am.
Dr. Arna ma'am, with your kind permission, can I ask another?
Yes, sir. Yes, sir. Yes, please.
Sir, this is quite some sort of personal question. It was a localized problem, but now it has become an that is national-wide. Everyone has have come to know about this. There is a unit in Neyveli, 2 into 250 megawatt, which is of CFBC boiler, and they say that that unit it can never reach the peak of its generation. That is 250 megawatt. It cannot reach. And even once I have got an opportunity to interact with the unit head of the particular unit, sir. But the unit head had said that it was the instructions that has been given to me by executive directors that this unit cannot go beyond 200 or 190 or some megawatt, he has said. What is the reason, sir? Or is it something that which cannot be revealed in publics? If so, it's okay, sir. But if there is a reason, and if you can tell it, can you please tell me any technical problem is there in that boiler, sir? So that we come to know the CFBC boilers.
Partially, you are right. That is, everything cannot be revealed. But anyhow, politically, I will try to reply. So the project which we have constructed at Rajasthan Bursing Sir, Bikaner district, is 2 into 125 megawatt. It is a different technology. Normally, the coal-based boiler.
Sorry to interrupt, sir. 2 into 125 is also CFBC, sir. But 2 into 125, you have gone to full power.
Yes, sir. That's what.
Let me. 2 into 250, you are not going to full power, sir. What is the? Okay, I'm sorry. Please explain.
So there it's 2 into 125 megawatt is used normally for the other boilers are PF boilers, polarized fuel boiler. That is it burns and goes to the second path and comes out. But here the unit which you are telling is a CFBC boiler, circulating fluidized bed
Fluidized
combustion.
bed combustion system, yes, sir.
Circulating fluidized bed combustion, which we have erected in Rajasthan. You also were there.
Yes, 2 into 150. Yes.
Okay. So for lignite, this fluidizing is not. It is not. It was not. What do you call? Balance. There must be a continuous flow of this hot particles of sand, which gives the radiation of the heat. It goes to the water walls, and then heat radiation will be there. So if we are trying to raise the fuel input to raise the heat level, the fluidizing imbalance is occurring. So whenever there is any fluidizing imbalance occurs, it is creating hot spots at some reverse chambers. So there, the temperature is rising at a higher level, somewhere around more than 1000 degrees. Silicon dioxide fusion is occurring and it is choking. So to contain that, what we have to do is, whenever there is any imbalance in the fluidization, we have to reduce the load. We have to balance again the fluid. The flow should be continuously balanced. There should not be any disruption. Once it is lifted, it should come down. This fluidization imbalance had occurred. As I initially I told you, there are certain things which cannot be explained.
See, please watch out. There could be some sensitive questions. This one is operational questions at a base level. It may not hurt the person. At a top management, insisting on answers like the sensitive issues really affect them. So please refrain. I mean, from sitting here, I may criticize Modi because I'm nothing. Nobody cares. If a defense minister criticizes Modi, next day he will be fine. So you have to bear that one. Use a little bit of your thinking. So the reason is Surya Narayana is near the board. See, there are some confidentialities. You may know they cannot be revealed. They should not be revealed, and you should not be asking such questions. So, mind you, although I'm harsh, we have to nip at the bud. So, some of the delicate questions, you can see how he was hesitating. So, that's why he went round and round and round. So, take it granted whenever you ask questions. A basic engineer to a management executive, the responsibilities are different. Okay? Any
Yes, sir,
others?
okay.
Please ask questions, any others regarding the technical thing or anything else. Or if Rajeshwari is there, please little bit give a brief of your, we are looking forward for your talk. An introduction to that one before we leave. Actually, the time is up, I think. Okay, Rajeshwari is here. Yeah, I like her face. So, okay, please give a brief introduction of what you are going to say day after tomorrow. And if Aruna can tell about tomorrow's talk also, that would be good. What will be?
Good evening, everyone. I'm Dr. Rajeshwari, Assistant Professor from Department of Life Sciences, Sri Sathya University of Human Excellence, Karnataka. Since few years, I have got this deep interest in neuro wellness, and basically, I'm going to highlight on the various methodologies and modalities as to how certain therapies can actually help us overcome the stress and anxiety which is built up due to the digital tools, or we can say because of the digital addiction that we face in nowadays. So I'm going to highlight more on different ways by which we can help our mood swings, and then the kind of anxiety and stress which is getting built up naturally through very various like various ways, I can say. So I think more details I'll be able to highlight in my upcoming session on Wednesday. So I'm going to address on the topic integrated therapies for neuro wellness. And I welcome you all to join my session, and let's learn and enjoy the session. Thank you.
Good, madam.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am. Thank you. Anybody else who wish to interact with the Suryanarayana, sir? Now I wish to have any suggestions to improve this lecture series, or any of your feedback, whether it is positive or negative. We are welcome here for 5 more minutes.
Madam, one suggestion that I have, not suggestion, one request. That is glass. On glass subject, if somebody gives a lecture, it will be very useful. It is a lot of developments are occurring in glass. I cannot use the word metallurgy, because metallurgy goes with the metal, and this is a silicon based, this one. That is, whenever I see any Chinese glass bridge, I wonder that how they are able to do it. I am eager for any of the lecture that somebody gives on this latest development of glass technology. Great use. So Mr. Shivaganesh also was telling, he was telling that from the first session, hard materials also will try to absorb the stress level. Same way that that bridge, glass bridge. I am interested in
Okay.
glass.
You are opening a can of worms. A glass science is a part of ceramics, but itself evolved as its own glass technology, silica technology, whatever it is. But what applications you want? What you want? Is it structure? Is it the application? Is it the degradation? There are so many issues. The reason is the glass plays in regular, simple structural applications or electronic applications. So many things are there, electro-optic applications. So the justify structures and all are how degradation. I understand your yesterday's question. In fact, we learn lessons from accidents. One day I had a furnace at the operating around 1000 degrees centigrade. I forgot it was made. The heating element is graphite. No, not, I'm sorry, silica. Silica, this one. I left it open, and somehow what happened, I don't know. I set it below 1000, it went above. And next day I came and opened the furnace. The furnace was full of like a cotton, which is dispersed all over, spread all over the furnace like a spider web. And you actually, the cooled furnace, you remove it, can make actually silica, that sweet candy they make.
Yes.
That's what it became. And it is all over. Easily you can peel it off, but thin layers which adhere to the structure. As you said, either you at a high temperature has to be removed, or you high temperature you apply and cool on the other side so that it cracks and falls down. So that is how they remove in your gas towers also, if at all there is anything. So that is the inherent problem with the low heat furnaces, lab furnaces, which are generally operable below 700 degrees or something like that. So yes, based on that experience, you wanted it. It's an interesting concept. We will find somebody who is who has done. In fact, all my colleagues, all my friends who were in glass technology, they are retired, and I don't know where they are, or else I should have asked. In fact, I was trained. I had my first PhD under only at that time they used to call silicate technology, as silicate technologist. Still, I will find out. One guy I know is a retired professor. I don't know whether he can talk. I mean, talk in the sense, I'm I'm surprised yesterday when I saw that YouTube talk. Then I'm using more of, I never used to have this one in my talk. There is no worry for me to look for words and fluently I used to talk. So this Gangopadhyaya, he was my friend, my senior. I will try to talk to him. He is an excellent glass technologist. We will try to find out and your suggestion is very good. Send just a text to Aruna so that she will not forget. And then I forget things easily. So there's such an suggestions, not only for him. We request from you guys. Actually, somebody may say, in fact, I forgot her name. She's from Haridwar. She wants activated charcoal. Activated charcoal has numerous applications, particularly as absorbents and all. These sort of things we may find somebody or even request her to give a talk on them. Activated charcoal, how to make it. Some people they make out of these coconut
Shells.
High coconut, they partially carbonize it and it becomes activated charcoal, this sort of thing. So I think these are the sort of inputs. Unless you have inputs, Aruna cannot think of. It goes into a regular type of. If it is a conference, people themselves suggest a name. Whereas if they have a detailed talk, in fact, even with Rajeshwari, I used Dr. Rajeshwari. The reason is I heard in a conference a short presentation. Immediately, I felt it's an excellent contribution by her student. So I especially requested Aruna to have a full detailed 1 hour talk so that everybody can understand. And immediately, Aruna also agreed with me. And she became one of the speakers of this special distinguished talks. So like that one, all the audience who are there, although it is a little bit late and everybody is hungry, I am also hungry for my lunch, for you guys' dinner. So please suggest what you want to listen, which type of talk will really entice so that you can spread that message to your friends also. So the more number of registrations Sidvi gets, it will be useful for everybody. So this is my concluding remark. And in fact, before others say concluding, I'm going to conclude and close it, then we'll have Janaganamana. Today's talk really is an eye-opener, both from the scientific point of view and the practical application point of view. And also how the management face the problems in the day-to-day operation or installation and operation of specific things related to power plants. And also how a top management looks, because for them only a little bit goes. Here I will say one thing. When I give my top management briefing, it should not be more than 5 slides. As a technical man, giving 5 slides and only the essential part, because they don't have patience to listen deep. Oh, my time is where I have to go, I have other meetings. So such a top management, how you communicate to that one, how it reaches, why it is necessary. And from that limited information, how those people with their tacit knowledge can completely visualize the whole picture and augment their sensitivities in releasing the public, because you say something, the press writes their own whatever, and nowadays that YouTube, every nonsense will be written. So this is how he gave, and it is really a wonderful talk. Although I was worried for the prolonged continuation, but he maintained where information has to be disseminated in a very patient and clear cut. So solid information provided, and where he has to accelerate. He went like a Tufan Express, and then concluded without any delay and exactly on time. So I have to thank the speaker for his wonderful talk. He's really a distinguished engineer with a lifetime accomplishment, and I'm sure the wisdom he shared today is his lifetime contribution, because I can use the term he is now retired. So we were able to at least grasp a little bit of his tacit, because business school people will know that from what I'm talking, his tacit knowledge on the power plants. With that one, thank you very much to the speaker, and thank you for letting me conclude by making myself available for this one to Aruna. Now, probably if Aruna is going to conclude, we can end up with Janagana Mana like yesterday. Thank you. Thank you all.
Thank you so much, sir. Thanks a lot for briefing the entire today's session and giving these concluding remarks. And I especially thanks to Professor Srinivas Rao sir and today's speaker Suryanarayan sir and Sivaganesh sir and other speakers for further sessions and the participants. Thanks a lot for sparing your valuable time to us and for enlightening with all your discussions and talks to this auspicious occasion. And I request both of the speakers are here and ma'am also there, Rajshri ma'am, to please be with us for all these 7 days sessions. And at last, on 7th day, we are having one like a common interaction session with all the 7 speakers. We are requesting the speakers to join again on that day also. So please make yourself free for us for sparing your valuable 1 hour time in all these 24 hours. Thank you so much once again. And now we can conclude this with Janagana Mana. I request all the participants to please stand before your devices and join your tone to sing Janagana Mana.
जनगणमनाधिनायक जय हे भारत भाग्य विधाता
Himalaya,
उज्ज्वल जल तब जय गाथा
भारत भाग्य विधाता Jai
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 Jaya
Jai
Jaya
Jai
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 Jai.
Thank you all, and officially I'm announcing that today's session has been concluded and it has been ended. Tomorrow, all of us, let us meet by sharp 7 p.m. Thank you so much.
Thank you, ma'am.
Thank you, madam.